Imagine a cat sealed inside a box. And in that strange box, the cat is somehow both alive and dead at the very same time. Sounds absurd, right? But this isn't science fiction. It's one of the most famous thought experiments in physics, Schrödinger's cat. And believe it or not, it could hold the key to understanding reality itself. Today, we're diving into the paradox that challenges common sense, shaped modern quantum physics, and continues to haunt scientists and philosophers alike. By the end of this video, you'll see why a cat in a box is much more than a weird metaphor. It's a window into the deepest mysteries of the universe. It's 1935. Physicist Erwin Schrödinger, already famous for his work on quantum mechanics, is deeply skeptical of how his colleagues are interpreting the strange behavior of subatomic particles. To make his point, he imagines something dramatic: a cat. Here's how it works. Inside a box, you place a cat, a radioactive atom, a Geiger counter, a vial of poison, and a hammer. If the atom decays, the Geiger counter detects it, triggering the hammer to smash the vial, releasing poison, killing the cat. If the atom doesn't decay, the cat lives. Simple enough, right? But here's the twist. Quantum mechanics says that until we observe the atom, it exists in a superposition, both decayed and not decayed, which means the cat is both alive and dead simultaneously. Schrödinger wasn't trying to confuse us. He was highlighting just how bizarre, maybe even ridiculous, quantum mechanics sounded when applied to everyday objects. So what's this superposition thing anyway? Think of flipping a coin. While it's spinning mid-air, it's not strictly heads or tails. Only when it lands do we see one outcome. In the quantum world, particles behave in a similar way. They can exist in multiple states at once until we measure them. Electrons, for example, can be in many places at once. Photons can act like waves and particles simultaneously. Your everyday reality, the fact that you're sitting there watching this video, is built on a foundation of objects that refuse to obey common sense. But here's the kicker. Why don't we see cats, or coffee mugs, or entire people in bizarre superpositions? Why does the weirdness stop at the quantum scale? This is where things get fascinating. Different interpretations of quantum mechanics try to answer the cat's fate. The Copenhagen interpretation, the mainstream view for decades, says that the wave function, this ghostly cloud of probabilities, collapses when observed. In other words, the cat is both alive and dead until you look. The act of observation snaps reality into place. But then came the many worlds interpretation. According to this, the wave function never collapses. Instead, the universe splits. In one universe, the cat is alive. In another, the cat is dead. And in countless parallel universes, every possible outcome exists simultaneously. Mind-bending, isn't it? A third approach is decoherence. Here, the idea is that the cat's surroundings, the box, the air, even stray photons, act as silent observers. They destroy the delicate superposition long before you ever open the lid, which is why we don't see macroscopic superpositions in daily life. 3 interpretations, 3 very different answers. And the scary part? They all predict the same experimental results. We don't actually know which one describes reality. You might be wondering, okay, but why do physicists still care about Schrödinger's imaginary cat? Because the paradox isn't just philosophy anymore. It's the foundation of quantum technologies today. Quantum computers, for instance, use superposition to perform calculations on many possibilities at once, making them exponentially more powerful than classical machines. Quantum cryptography uses these principles to create secure communication that's unbreakable by any known method. And in labs around the world, scientists have managed to create cat states, putting not just particles, but even large molecules and mechanical systems into superposition. Each new experiment pushes the boundary of how far into the everyday world quantum weirdness can reach. So let's circle back. Is the cat alive or dead? Schrödinger never intended us to pick an answer. The point was to show that quantum mechanics, while astonishingly accurate, forces us to rethink reality itself. Are we collapsing possibilities by observing them? Are we branching into infinite worlds? Or is reality quietly choosing outcomes long before we peak? The cat remains in the box, and the mystery continues. Which interpretation do you believe? Collapse, many worlds, or something else entirely? Drop your thoughts in the comments. I'll be reading them all. And if you want to explore more mind-bending science mysteries, make sure to subscribe so you don't miss the next video. Because in this universe, your curiosity is alive and well,